Oh, hello again. It's October 1st, 2013, and for today's problem of the day, I made an SAT problem. And I did this because many of you will be taking the SAT on October 5th, 2013, and that happens to be on Saturday. So, just a little more than a few days away. This is a problem that incorporates two algebraic techniques needed to succeed in the SAT. The idea of ratios and also the idea of systems of equations. So let's look at the problem. It reads, a bag contains tomatoes that are either red or green. Initially, the ratio of green to red tomatoes in the bag is 4:3. After 5 tomatoes of each color were removed from the bag, the ratio of green to red tomatoes becomes 3:2. How many red tomatoes were in the bag initially? Alright. First thing I need to tell you guys is you need to be very, very, very careful when you're reading a problem in the SAT, because the SAT really likes to use the wording and the English within the problem to say a lot. So let's look at this problem. It says we have a bag of tomatoes and they're red or green. We don't know how many tomatoes are even in the bag, but we know that all of them are either red or green. And then we know initially the ratio of green to red tomatoes is 4:3. So how do I express that mathematically? Well, there's a couple ways I can do it. The first way I can do it is with a fraction. And if I let G be the number of green tomatoes and let R be the number of red tomatoes, I can say G over R is equal to 4/3, right? Or I could say that R over G is equal to 3/4. Now, either one is okay. So when you think ratios, you're really thinking fractions. Okay, so either one's okay. I'm going to leave that there for right now. What else does the problem give us? Well, it tells us after 5 tomatoes of each color were removed from the bag, the ratio of green to red tomatoes becomes 3:2. So you gotta subtract 5 from both G and R. G is the number of green tomatoes, R is the number of red tomatoes. So what this second bit is saying down here is that G minus 5 over R minus 5 is going to be, instead of 4:3, it's now 3:2. And so we write 3/2 because we had the greens on top and the reds on the bottom. Okay, so that's what we get from that bit right there. And now, it may not look like it, but we actually have a system of equations. Remember, a system of equations is a m equations with n unknowns. And here we have 2 equations with 2 unknowns. Our 2 equations are right here and right here. And of course we could have used this one instead of this one, but I didn't. And it's perfectly fine to use either one. Okay, so now we have these two systems of these 2 equations in our system, and we have to solve. Now, if you'll remember from Algebra 2, you know that to solve a system of equations, there's 2 main algebraic methods we use. Let's not think about the graphical method for right now, because we're dealing with the SAT. The algebraic methods are substitution and linear combinations. Seeing as this isn't really written as the typical linear equation, why don't we go with substitution? And basically, what we want to know is the number of red tomatoes that were initially in the bag. Okay, the number of red that were initially in the bag. So we want to know this. We want to know R, the number of red tomatoes. And when I wrote that, I meant the number initially in the bag. You'll see as I subtracted 5 after the fact. Okay. So what we're going to do here is we're going to solve each of these equations for G. So I have this one. And to solve this guy for G, all I'm going to do is multiply by R on both sides. When I do that, the r on the left side cancels out, so when I multiply by r on both sides here, the r's over here cancel, right, because r over r is 1. And then we get g equals 4r over 3. Okay, now let's look at the second equation we have. We have g minus 5 over r minus 5 is equal to 3 over 2. Okay, well, why don't we just multiply both sides by r minus 5? That maintains the equality. Multiplying something that's already equal, the same on both sides, maintains the equality. And basically we do that so we get rid of the r minus 5 down here, and it becomes g minus 5 equals 3 times r minus 5 over 2. Okay, well, let's simplify this a little bit, and I'm just going to simplify the right-hand side, so it's going to be 3r minus 15 over 2. I just distributed the 3 to the r and the negative 5. Okay, now the last thing I'm going to do is I'm going to add 5 to both sides. So I get g equals 3r minus 15 over 2 plus 5. But seeing as we're working with fractions, and when we add two fractions together, we have to have a common denominator. Let's rewrite 5 as something over 2. So I can rewrite 5 as 10 over 2, right? Because 10 divided by 2 is 5. So it's the same thing as writing, we can write 5, or we can just write 10 over 2. So we're going to write 10 over 2 because then we will get that g equals 3r minus 15 plus 10 over 2, or 3r minus 5 over 2, right? We added these two guys together and we got minus 5. Okay, so now we have these two guys that we're left with. And since g equals 4r over 3, and g also equals 3r minus 5 over 2, then aren't 4r over 3, isn't 4r over 3 equal to 3r minus 5 over 2, because they're both equal to g? Yes, they are. So 4r over 3 equals 3 head, and the least common multiple between 3 and 2 is 6. So why don't we just multiply both sides by 6? So when we do that, we get 24r equal 24r over 3 equals multiply by the 6 over here, and we get 18r minus 30 over 2. And that can simplify to 24 over 3 is 8r equals 18r divided by, we can break this guy up right here as 18r over 2 minus 30 over 2. So the first guy there, 18r over 2, is going to be 9r, and then minus 30 over 2 is going to be minus 15. Okay, so how about we just add 15 to both sides and subtract 8r from both sides? So we're going to add 15 and subtract 8r, add 15, subtract 8r. When we do that on the left side, the 8r's are going to cancel out. 8r minus 8r is 0, so it's just going to be 15 equals, over here, the plus 15, on the right-hand side, the plus 15 and the minus 15 cancel out. So you're left with 9r minus 8r is just 1r. And wow, what do you know? R equals 15. 15 is the number of tomatoes in the bag. So I hope this helped. This would be considered a hard SAT problem, I guess. And the things you needed to know about them were how to do ratios and how to do solving a system of linear equations. But what was really important was also paying attention to the language here. This this type of thing where it says each color is monumentally important. Also is important is understanding actually what you're being asked, introducing some variables. All these are ways to problem solve effectively on the SAT. So there are quicker ways to do this problem. I present it this way because if you understand this, that's the first step to doing it a little quicker. I hope you enjoyed it, and if you need any other SAT math help, please visit my website, onlinemathacademy.com, where I do math tutoring and test prep online. It's great, it's easy, it's convenient. I record every lesson, and students can watch them as many times as they want at their convenience. So it's a really fantastic service. I invite you to check it out, and I'll even give you your first lesson totally for free. Totally for free. Don't give me any kind of credit card information, nothing. Just let me show you that I can help you out. Thank you for watching this video, and good luck on your SAT.